single flame can light a million more.
Well, here we are on the last sb220. Well, Charlie here, he sent this puppy up, and he wants me to do a bunch of upgrades to it. He wants me to put the soft key in it, soft start in it, which will end up probably being somewhere in here. Soft key, it's already got an auto key thing set up here. And, you know, before you start, you got to really look close at everything. Somebody's already been through here and did some suggested ham thing that has got a resistor and a capacitor on each one of the ground tabs for the grids. We're going to do away with that. This filament choke circuit here, which obviously hasn't worked too well since it's all burnt up. I think they got that driving the lights for some reason, instead of running that off the Harbach board that's on the back side of this thing, or the top side of this thing. You gotta look close, because the details will jump out at you. They have this mono-banded, so you can clearly see somebody cut this. So the coax comes straight in with no tuning, goes through the relay, and then into the tubes with no induction tuning or nothing. I'm not quite sure what the backstory is, but he wants me to restore this thing and make it work the way it should. And then on the top side, you guys will get a kick out of this. We'll talk about this here in a minute. Yeah. And then it's got the small caps in it. But it's got every Harbach mod to it that you can think of. Had an aftermarket Zener in here for the bias control at some point or another, but they moved the plate choke off the wall here, and then they've got a double set of blocking caps here that, oh yeah, Charlie, you weren't lying. Look, these son of a bitches aren't able to stay around. They're soft like putty. We've dealt with that before. And then this here, this is not stock. It's not the way it's supposed to be. Every single one of the taps coming off the coil, that's been all modified. That 1000 puff cap down here has been cut, and this whole drive section has been bypassed. So, man, come on, you guys. Look, you got to have the dual facing diodes on the plate ampere, but the grid, you can only have the diode facing one way, towards the positive lead. Otherwise, it'll make this read not appropriate. This does have the late generation rectifier board, and then somebody's gone in here and they've got the good 6 amp diodes in here. But wow, there's a lot we got to do to this. Anywho, he wants to make it work on all bands, 80 through 10. He wants everything indexed, and then he wants all the inputs tuned. So, new doorknobs, remount filament transformer, double check high voltage capacitor, rebuild output tune network, rebuild input tune network, and yeah. Oh yeah, he wanted new parasitics added. Now, in theory, this will work. They've got a piece of high volt lead that comes off this connector, runs down, goes along the bottom of the cabinet, comes over to this 1000 puff blocker, runs through a separate plate choke, and then goes up through the big plate choke. After it goes over another, or not blocker, but bypass cap. That's a bypass cap too. These are your blockers. But moisture has gotten into both of these. This has got an aftermarket, it's like this is supposed to be a little triangle thing, and then there's a 1000 puff doorknob that sits here, and they've changed all that around. That's not necessarily wrong. This is just different. That and these caps of, well, when you can squeeze them and they're soft, that usually means they're bad. That means moisture's got in them and they'll conduct. So, seeing worse, this ain't no big deal. Alright, let's take the face off and get the input circuit set up the way it's supposed to be. Anywho, here we go, Charlie. Okay, Charlie. So we got the face off, and I went ahead and I rebolted this down. This is your filament transformer, and this is also the voltage reducer that, well, not voltage reducer. This transformer runs your light bulbs, your filament, and your fan. And we got this all bolted back in. Now what we got to do is we got to replace the coaxes that come off the band switch in the front so we can make this functional again. Now I've got several different choices here. I don't keep RG58 in this shop anymore. It's just too low a wattage and doesn't do anything for me. It doesn't get my juices going. So I've got M17, which is a mil-spec coax, which has got a Teflon center conductor and a steel center conductor that is silver plated. And then I've got all this smaller stuff. This is some dual shield stuff that I use for the output circuits and boxes. Here's the input stuff I use, which is a single shield. A little bit less wattage, a little bit more wattage. Then we have this Scoochum Cool stuff called RG400. It's a lot like M17. It's dual shield, Teflon center dielectric, but the center conductor is stranded. So it shares a lot of the same properties as RG58 as far as size goes, but its wattage handling capability, Scoochum more, much more. So I'm probably going to use RG400. Hope you don't mind, I'm going to use the $9 a foot coax. So we're going to go ahead and we're going to get that run. We got to pull out this one lead, and then I got to skin back the lead underneath, and there's a couple different things I got to do. But we're going to walk you through the process. And remember how I said those two little chokes that come off the filament on the bottom? I figured out where they go. They've got this come over here to the sensitivity knob, and they're using this as a bias control, which is really Scoochum Cool. I'm going to leave this in, and I'll show you how to use this when we get farther down the road. That's freaking neat. That's a neat mod. I've heard of this. I've never seen it till now. Shoot, who was the first one to tell me about that? I want to say Mean Pill, but no, I don't think it was Mean Pill. It was... I'll think of it. It'll come to me. We're not going to hold the show up. Why I've got it here, I'm going to bend the grounding tab out of the way. I always forget to do that. I don't want to end up taking this apart to rebuild it. Okay. Let's do our magic. Man, it's time to quit. Shit's getting blurry. I had a customer call me today, and he says, man, you know, for somebody that stands alone in his shop and talks to a camcorder all day long, I've sure gotten to know you good. Stopped and I thought about it. I'm like, yeah, this is a window into my brain, because this is all I eat, shit, and think about. Damn amplifiers. Well, Charles, I spent some time with the bottom side of this sb220. And what I mean I spent some time with the bottom side of this sb220, if you look at the previous video versus what's in front of you now, there's a lot of little changes. your soft start is installed. I hold very little faith in these. They make the amplifier weaker in my opinion, but you wanted it installed, it's in. So for all of you that wanted to know how to install one of these properly, I added these solder rings and this lug, but according to the manual you're supposed to twist these underneath these two tabs, and you're supposed to twist and lock it onto here. They send no standoff hardware whatsoever, so you'll find underneath this is some Captain high temperature tape, and then you'll find that there's 2 layers of double-sided stick tape, and then the whole thing is supported on that nut and then supported with this nut. And then I went over here and I modified and added the bridge rectifier, which is very confusing how they have the thing stated in the instruction manual, because one of the AC legs here actually goes to ground here, so there's only, anyhow. So how this works is that both of these relays are 48 volt. Well, there's 110 volts on this circuit. So you have relay coil, output of relay coil, and it goes through a little knockdown resistor, and then relay coil, and then the other output of the relay coil. So they have these tied in series with a resistor in between them. What they're relying on is a little bit of weep current to flow through these two 10 watt 20 ohm resistors, and for you to be able to charge the circuit. The circuit will slowly charge, charging the transformer, i.e. the filament transformer. It'll spit out a little bit of 110 current. It'll get rectified into DC because of the little resistor in the middle. As the current stacks and slowly builds, it charges up this capacitor that's sitting here. And when a current gets sufficient enough to actually latch the coil shut and connect the relays together, chink, these two sandbar resistors get bypassed and lets the full inrush of either 110 or 220 come from your breaker panel. The only thing I got left to do on the bottom side is I got to replace the 220 cable with the new one that you sent. Appreciate that. That's how the soft start circuit works. So look at how that's oriented in there. One leg of the bridge goes to ground. The positive leg goes to this terminal. Now what you're in sense doing is this coil here worked up at this point until 110 DC, or 110 AC. The coil doesn't care if it's AC or DC current. It does not give a shit. So by converting this to 110 DC, this relay will still function. Now, the other thing I did is I pulled out this bullshit soft start circuit that was built into here, which works fine. It's just an auto key circuit. That's really all that is an auto key transistor. So this is an NPN, negative, positive, negative. It takes a little bit of weep current that comes from the input coax here, charges through this disc capacitor, runs it through the little diode across a capacitor, and gives a little bit of positive current, charging the transistor, causing the gate to close, which in turn fired the relay. Well, this is a little bit different circuit, so I'm sure this is going to work just fine. This is designed to run with the AC current going into it. But now since we put the soft start circuit in there, we'll see if we get DC. While this is DC, it was only single phase. Actually, now it's full wave. So I'm pretty sure that's going to work just fine. I modified your operate standby switch. It's in the front. So this will work just as it did before, but I had to change how it was wired on the inside. The other thing I did is I attached the band selector from the front. So now this thing will work on all modes and all band. The 80 through 10. And then I changed the output. Now, there was a bunch of little horse shit that was around each one of these things. Now, in my extensive reading, they have changed the coil, little chokes that were in there, to these hand-tied wire wound chokes. And then across that they put a resistor and a little bit of capacitance. I'm not a big fan of that. Because the same thing happens if this choke opens up, the grid doesn't have a source back to ground anymore, and then you have your same problem, an instability, then one of the tubes goes to full punishment. I don't like that. I grounded the grids. This is the most stable way to make the box run. Now you'll hear the ham guys out there crone on that there's not enough capacitance present in the 3500Z tube, in the grid, that you need the neutralization portion of the process with a little bit of capacitance to help the tube become stable on 80 meters. Man, I tell you, listen to me when I say this. Ground the grids. The tube is resonant from 0 through 50 megahertz easily with a grounded grid circuit. You don't need a little bit of weep capacitance with passive inductors. It does 0 for you. You show me an sb220 with grounded grids. Wait a minute. Oh! I can. This, in a sense, acts like a fuse, if anything. So when the tube goes bad and the grid shorts out on the inside because the tube's been run to the end of its life, this will burn and open up. Well, so will this. The fuse burns up, and then guess what? The capacitor burns up. It's still a grounded grid circuit. So why not just flat out ground the grids? There's no more isolation. You're not going to create any more kind of reduction in the tube's ability to stay stable. Give it 100% of ground and let's move on. This comes from the guy that's got about 100 of these boxes out there with full grounded grids, and they're all ham guys, and they're having a blast with them because the amps run great, super cool, and stable. Okay, I got it out of my system. I got it out of my system. This is a neat circuit. My buddy, Mr. Collins, he's the one that told me about this. I knew it would come to me. I knew it would come to me. Old Mr. Collins, he told me about this. And he goes, and the pot on the front of the thing for the sensitivity is just the perfect value for it. This is an adjustable bias. You take your bias lead, or if you have the zener, you take the zener and you run it through this potentiometer. And then you tie that back in so you can change your bias and run it up and down, which allows you to change how reactive the tube is when it goes into transmit mode. Scooch 'em cool. I can't wait to see how this runs. I'm sure I'm going to have to modify this circuit just a little bit, just like I've done everything else in here. Added the disc capacitor here on the keying circuit to make it a little bit more clamped when we go to switch to ground, because that was missing. And let's see. Oh yeah. The input coax, they never took the time to solder that down. It was completely free floating. So we soldered that down, cleaned up that connection a little bit, and let's see, neaten up all the wires. So that's that. Charles, the bottom side of this box, short of the power cable, which I'll do first thing tomorrow, is done. It is 2:30 in the morning, and I'm going to go in the house. I got to get up and come back out here tomorrow, and I'm getting a little blurry-eyed, so it's time to unplug the irons, shut off everything, and go in the house. It's going to be pretty when I'm done. Hell, it's pretty now. All neatened up. You're going to enjoy this box when you get it back. It's going to run as stable as they get. Anyhow, Charles, through the magic of cinematography, tomorrow will come in just a blink of an eye. Man, oh my. Well, Chet, we got a short and a dangle. I don't know how else to put it. I got this whole bleating thing to go together. And I got it so the tubes turn on now. Woo! And I got it when I step on the foot pedal, I don't have arcs blowing out the high voltage side of the box. But when I go and I key down, it is showing me a short. So that tells me that some of this older than me coaxes in this thing has gone to ground. And I have half a mind to pull it all out and start over. But since this is day number 2 on this amp, this singular amp, I'm starting to get real close to what this guy's limited budget's going to be for this box. Let's see if I can figure out which connection it's at. These are real slow bleeders too. Really slow bleeders. No, wait. Check it out. Slow. It's okay. I'd rather have slow than too aggressive. Alright. Now I gotta go through the coax. God damn. Alright, I'll be back. When we come back, it should be chooching out some juice. It's the sb220 from hell. Once I get one problem overcome, another one pops up. All that shit's bad. Or has tested below par. So as you can tell, the faceplate's off it once again. Finally got the input adjustment kind of right. Somebody's gone in there and added a bunch of caps that didn't need to be on the input tuners. So I got that to lay down. But now I'm getting no resonance out of the output side, which is this here. Which, as you can see, this has been extensively modified. Now, if you guys can remember, it had this weird funky thing where they'd mono-banded it. I don't even know how they would have ever made this work without having an antenna tuner in the front and in the back of this thing. But add a new parasitics to it, and then I completely rebuilt this with some parts from a donor amp. The plate choke was junk. The second plate choke was junk, so this one was junk, that one was junk. The doorknobs they had in there are the consistency of rubber bouncy balls. And they had these 2 other blocking or bypass caps, 1,000 something and 1,000 something, and then they had this modified horse shit up in there. Look, every one of these is like a little riddle, right? Some ham guy or some dude that thought he knew something about touching his penis decided he would get in here and modify something, right, to make it work for his little special application. Somebody buys it, they go home and they think they got something because it says this name on it that it's going to work the same, and it doesn't. So being that I am like one of the last men on earth, one of the last Mohicans out there still willing to do these kind of headaches, and I spent 2 days on this so far, you guys, chasing down all this stuff. That's all the extra pieces. That's pieces and parts and shit that just found our dingus and went to ground. Anyhow, so man, what is this? 2:30 in the morning. We're probably gonna go into day number 3. And people wonder why this takes so long. It's like one problem after another after another. So it's like you get to a certain point, and then you go, okay, the next stage in the equation is that you can't just... Okay. Oh, man. I think I'm going to put this puppy down. I'm going to come back to it tomorrow. It's been a long day. I've been staring at this thing most of the afternoon, going, what's next? I mean, even little things like all the solder joints on the selector knob were all cold. Okay? Don't know this till you turn it on, and then you got to run those down. I had to take the capacitor bank apart because there was cold solder joints in the capacitor bank. Well, that takes a bit of time because then you got to undo the bottom of it, take the whole capacitor bank, redo the whole board, put it all back together, solder together. 2 hours. Chasing down why my input tune would not work. So this little cap right here on the 10-11 meter band. I see it's also here on the 15. They've got one added on the 15. And none of this looks right to me. I've looked at this and looked at this. I'm going to have to go through all of this. I'm going to have to trace out every single wire and make sure they're wired in the right place. And then we got to go down here to the metering circuit for the LC. So, because we got extra wires that are added to this. We got to get that sorted out too. One thing after another. But eventually I'm going to get this sumbitch. You watch. I'm going to make her tighter than a German virgin. Alright. Good night. I'll be back. Woo! Getting dingy. Come on, old man. Let's go in the house. The amp that won't keep giving me the fucking headache. Right now, the owner of this thing has got to be freaking out. What did you do? Well, I got it all put together. I went and loaded it up, and I ain't getting no power. No power. No power. No power. Circuit. You can measure with a scope. I got power going in the tubes. Got the RF going in the tubes, and a little bit of RF coming out of here. But it's hitting like a brick wall, like it wasn't even remotely in resonance. So, now this is bad. I've got to rebuild all of this. So I wasn't too overly concerned with how it came out. Now, I don't know if you guys have ever had the pleasure of looking down back in behind an sb220 to... Let me grab this one here. Down in there, down in that black vaginal cavity, that void, is the band switch. And you cannot see it. I don't care how you put your flashlight upon it. If you get down in there with a little mirror and microscopums, you might be able to see it. But I was sitting there playing with it, and I could take the front knob and just push it in, pull it out just a hair, and put out some power. I went, band switch. Chooched. Not the front one, the back one. If you look right, let me point something to point with here. If we look right here, you'll see that this tab is burned off. This tab isn't making contact. This one's bent, and that one is completely burned off. The other side, the tabs are held on by solder. As you can see, there's big balls of solder hanging out here. Those are screws, but this one's been soldered over. Now, the other part that you might not have noticed is this. Look at how heat scorched this is. Now, this was mono-banded, but it had no input tuning to it whatsoever. So, I don't know how or who owned this thing before, but this thing's royally fucked. So I had the debate. Do I want to take the coil out, undo the capacitor bank, pull out this disc coil, and undo all that shit just to get the switch out? Or should I take the whole duct pluck and mess out? Because I got to replace all of this. All of this has got to get redone now. Because these, after doing some checking with the assemblage manual, weren't even on the right fucking taps, man. So it wouldn't have mattered how much juice you put into this thing. It would have never chooched. All out of whack. I worked all day today. And I come out here at about 9:30 this evening, and it's now 1 o'clock in the morning. So the goal is now I got to take this out and I got to retap it. Okay, so what I mean by retap is I got to change these leads out. I go ahead and scrub the rest of the box out and get all the other cigarette jizz and shit out of here. I got to remount the filament transformer because that had to come out for me to get this section out. And I wanted to take this out in one piece. Why? Because it's attached to the unobtainium bit. I don't want to do anything to jeopardize that perfectly working band switch. And now, since I took the time, the first thing I did when I come out here was completely double check every single wire lead that come from these chokes. And guess what? Wired backwards, and then there was all this funky shit added that was causing the input tune on every single one of the bands to be off. Just flat out off. This box has been fucked from the word go. I don't know by who. I don't know by who, and I don't ever want to know. Because if I ever meet him, I'd kick him a swift kick in the nuts and say, stop! You know not what you do, stop! Okay, so, like I said, I got to clean all this up. We're going to make this look like new. Because that's what I do here. Now, my instructions were very specific to do whatever it takes to make this thing work on all bands. Now this is the hard bit, you guys, and this is the honest to God truth. If I was to bill this guy for every hour I've spent on this box, I would own this thing. I don't want to own it. I want to see this go out the door and go to him and he be happy. He be jamming. And getting his call sign called all over the place. So this is where you got to have a little bit of tact and couth and go, well, how much of this am I going to write off? Look, I ain't going to let this thing kick my ass. I've never had one of these things come in here that I couldn't fix. You know, I've only had one of them I sent away because, well, the guy was a douche and harassed me on my fucking honeymoon. I sent him back his box, but I've never had one of these kick my ass. I'm going to fix this thing. But since yesterday, I've been on this for free. Meanwhile, I've got all the other guys in the gate behind you waiting to try to get up on the bench. So far, this is how much stuff I found that was wrong, wired wrong, not even remotely right, or stuff that was added that didn't need to be there because somebody else had some other purpose in mind. This just goes to show you, whatever you buy off eBay, is it really going to be worth it? Is it really going to be worth it? Okay, the more time I spend standing here talking to myself, the less time I spend working on this thing. So, through the magic of cinematography, let's be back together. Bye. Okay, so I lied. It's not back together. I wanted to show you how far I took it down. Cleaned out every one of these sockets and holes. Got this all cleaned up. I took this tuner out so I'd have a little bit more room to work when I go and resolder this back in. Yes, I used silver-plated, copper core silver-plated Teflon jacketed wire. Why? It's got way more surface area than a solid piece of wire. And it's silver-plated, so it means it's got a little bit less contact. But it's a lot easier to work with. Primary reason. The band switch, the stock one, pure shit here, is, well, I'm never putting this thing back into anything ever again. It's going to go in the trash. But what I thought was really cool, let's see if I can find a little hunks of shit that come out of the switch that I put in here. This one here, which is in far better shape, not burnt to Jesus. Oh, I hate, if anybody that knows me knows I can't stand having my workbench like this. I just want to kill myself. I'm very methodical normally, so here, look at this. Look. In the instruction manual, it tells you to take a piece of a needle nose and the silver-plated wire that they have in there, they crimp this down and they flatten it out to go through the slots. Because you see those holes are not really rounded in these little tabs. They're not round. They're oblong, kind of oval shape. So to increase the surface area of the contact to make it fit. So this, I don't know. The only thing I might save out of this is the silver-plated strap, but it's been chooched pretty good, so I'll probably use some silver-bladed braid, but braid's got a little bit slightly different resistance value to it. But anywho, this was an original stock switch that was from the factory, and I can tell that by looking at these end bits that come out of the switch itself, because it's flattened, because that's the way they tell you to do it in the instruction manual. So yep. Okay, next step. So it's 3:30 in the morning. I started my day at what? What was that? 8? Only a 20-hour day. I can do better. I can do more with my day. 9:55. Going into this mess. I got a little couple things I got to do on the input tune yet, but 1,000-watt slug and 2 eggs. Hello. That's 1,500 watts with 90 watts of drive. Oh. And the band selector's working. And it's working the way it should. And it didn't have any bunch of hodgepodge bullshit in it now. apparently I've got a couple of the input capacitors have gone tits up towards God, so I've got to pull those out and check all of them tomorrow. But it's 3:30 in the morning. I'm playing with 3,000 volts worth of jizz. And by the way, all the meters are working perfect now. Oh man, get too old for this shit. Fixing other people's stuff. It's easier to build them from scratch. It really is. Shh. Good night. Okay, Charles, guess what? Everything works. I spent a lot of time working on the band selector on the input side. What we're going to do is we're going to set the camera up so we can see all three things: radio, input tune, output power. So let me get this thing slapped on the tripod and we'll get started. Okay, so first we're going to start out on 27 megahertz, 10 meters, give or take. And boy, it's been a lot of work to get this far, you guys. You have no clue how many times I've had to take this stupid thing apart and put it back together. This is going to show us our input drive, and then I'd normally use a 5-watt slug, and that's what everybody's used to seeing. But if you'll look, most of my 5-watt slugs are 25 to 50 megahertz. So what we're going to have to go with is the Coaxial Dynamics 2 through 30 megahertz slug. Now, if you blow this up on a big enough screen, you'll be able to see that this thing's barely moving. Now, in the background over here, we have the 1,000-watt meter, and this is in PEP, by the way, you guys. So I'm going to show you 1,000 watts in PEP, and what we're going to show you is that with about 100 watts of input drive, this box will do 1,000 watts, and it has relatively good input tune. So we're going to go through each one of the bands. We're going to do 10, 15, 20, 40, and 80, and show you the response of each one of the bands with the box. So let's start out with 10. Hello. Hello. Why are we in sideband mode? What I am. Hello. Hello. Alright. Flip the slug around, so now we're reading in reflect. Hello. Hello. Audio. Hello. 890 watts of 890 watts of PEP power, with about 90 watts going in. Less than a watt of reflect coming back to the radio. So now we're going to change bands. We're going down to 15 meters. Click the band switch down to 15 meters and let me reload it. Let me show you what I'm putting into it for drive. About 120 watts. Getting no reflect back out of it, and it's jumping over there to about 1,1300 watts of power. So now we're going to flip on down to 20 meters. Right in the middle of the 20 meter band. Let's reload it. About a watt worth of reflect. That's in PEP too. Wow, check this out. This is what I'm putting into it for drive. About 110 watts again. So now we're going to jump on down to, let's see, 40. It's right in the middle of the 40 meter band. So your reflect at a whopping 4 or 5 watts. And we're getting what? Putting 100 and what into it? Audio. About 90 into it. 80, 90 into it. We're still getting 11, 12 out of it. So let's go on down to 80 meters. Let's get this out of the way. Hold 2 or 3 watts of reflect back on 80. Putting 100 into it. Let me play with that. Just give me a second here. Let's readjust the amp that won't stop giving. That is a backup band selector that I have. I'm going to pull this tuner out because the one that's over here in this one, I just made the observation. It's this one right here. Focus. This one right here is held in there with super glue. And I can't get it to tune down. So, yet, one more thing I'm going to fix on this deal. So give me just a minute and we'll get that squared away. Well, here's the offending little booger. It's not only been super glued together, but it's cracked. Put this over here with all the other stuff that I've had to completely replace. Okay, let's see. So we're getting 5 watts of reflex, 6 watts of reflex before. 80 meters. Getting a needle's width with a 100 watt slug now. Let's see what we're putting into it for grounding. About 220 or 120 watts. We should be getting about 1300 out of it on the peak side. Get right on the money. Like 11 to 1 peak power. Anyhow, that's in 2x now. And we were getting 1500 out of it. With 120 watts of drive on 80 meters. With no reflect. Okay, yay. Hello. Viviaga down. This amplifier has been a try of my patience. So, yeah. We'll put the tin on it and we're going to shoot the wrap video. So, give me just a minute. We're going to tie this puppy up. Alright, I'm going to shoot the high power test now. We're going to use the 2950, the old bench 2-pill. We're going to put about 230 watts into it. This is on a 5,000 watt slug. So, of course, the 10's 1,000, 20 is 2, and the 30 is 3,000. So, audio. Audio. Done. Absolutely done and done. 100% done and done some more. Whew. Man. Your operate standby switch is working. This is your ALC. Now if you want to get an automatic limiting control gauge and put it on the other side of this thing or use it with your radio, this is how you adjust your sensitivity. They had this set up to change the voltage on the bias on the tubes, and the box was so unstable running like that, I couldn't in good health send it out of here looking or running like that. You turn this knob just a little bit, and the difference between would be 1 watt and a 500 watt carrier. Just a little tiny turn. Oh, bleeders work good. All the meters work. The relative power and the grid meter all work. The sensitivity all works now. Let's slowly turn this thing up on our side here. Do this and not electrocute myself will be awesome. There we go. Aw, damn, the only thing I got left to do is put the power cord on, so I'll do that here in a minute. Charles, it's all in there, buddy. Your soft start is in there. Your soft key is in there. I removed the other soft key. Band selector's all working. All the chokes are working. Yeah, dude, this was a mess. This whole thing was a mess. I grounded the grids. This disc capacitor was 0.02 instead of a 0.01. What happens there is it allowed AC current to come back and back feed through the band selector back to the radio because it didn't have enough high enough capacitance value. So it made the tubes, every time you key the pedal, the tubes would bright up, just get super bright. Oh man. New rectifier for the relay control. That's all in there. Redid your power wires. This sucker is wired 220 at the moment. Put in the disc capacitors of clamps. These help clamp out a little bit of noise. Replace the input coax that comes from here to there. Oh, let's see. Let's go over here to the top side. I had to completely rebuild this entire portion of the deck. From the output to where are we at with voltage? Ground this bastard out. So when it showed up here, I had coming off the back of this insulator a piece of high volt wire that came down and went down the length of the cabinet and ran around and went across these two doorknobs. Then they had the plate choke mounted vertically. Now, somewhere in this plate choke is an open, because no high voltage can get across this choke. So this is a brand new choke that's in here. They had the secondary choke down there between the two doorknobs. It also had an open in it, so I replaced that with a new plate choke. Both of the blocking doorknobs they had on this modified panel. This modified panel right here. I went ahead and I put the stock blocks back in. Both of these caps, one has a value of about 50, and this one's got a value of about 400. The problem is that they're soft. You can squeeze them. You see how it's not round anymore? It'll spring back in just a minute. Here, you can squeeze it. It's like the consistency of a bouncy ball. So we got this whole thing put back together, and I got the whole front end to where the band selector was working again, which was a chore. And I go to fire down on it, nothing. I get nothing out of it. Not a damn thing. So that's when we found out about this mess. This band selector is burnt and scorched, and several of the tabs are so mangled up they're not making contact anymore. So I had to take the whole thing back out again. Take the whole thing apart. Ended up taking this tuner out also and cleaning it. Clean the entire inside of this thing. Put a new band switch in there. Re-indexed it and got it going right. I took your whole fan apart and cleaned it. As you can see, it looks like scooching new now. That was brown gray. I took all the oil out of it, cleaned it all up, re-oiled it. Nice and quiet. New parasitics, and then proceeded to spend all day today, about 3 hours today, getting the input circuit perfect. I had 80. When I brought it down to 80, I thought 3 or 4 watts of reflect was acceptable, but I got the rest of these to dial down flat, so when we came back to 80, I went to adjust the 80 slug, which is in here. Oh, the other thing is every single one of the Mylar caps in there for the other bands, 10 and so on, 10, 15, 30, 20, and 40, I had to replace all the Mylar caps because they were flat out either the wrong value or were no good. So this is the leftover hardware. Replace this soft key circuit. Oh yeah, when that back band selector burned up, it burned up good. No, that's not a match. That's a piece of fiberglass and Bakelite resin to plastic that goes through the back band switch, like so. And at some point or another, when that thing chooched off, it really went good. This is all the extra hardware and extra parts and stuff that I had to either replace, figure out what was going on with it, or rework. And I hope you enjoy this. I hope it goes to a good home. I hope that you take good care of it. I hope you really appreciate it, because a lot of love has gone into making this box work and work well for you. But it is perfect. And it's ready to come home to you. I'm going to put the outer armor on it. I'm going to get it all finished up. Put the lid on it, get the sides put on it, and get it ready to go. I'm going to replace this power cord real quick, and then I'm going to be back. I want to show you guys something. I want to show you guys something when I get back. So we're almost done. Oh, look, I have a clean work surface. I feel much more peaceful inside now. Guys, I want to show you this. This is a donor amp. It showed up here and the whole front end of this thing was destroyed. The knobs, the meters, and everything. And I ended up getting this thing. The guy just said, keep it, because it wasn't worth repairing. He got his money out of it for the insurance, but I have robbed countless parts out of this that are completely unobtainium any other way. If you got a smashed up sb220, I want to buy it from you. This amplifier, this donor amplifier, has allowed me to fix 12 other boxes with actual parts. Nothing has had to be jerry-rigged or, well, I've got another little thingy that it's actual parts that come out of another sb220. I mean, I have robbed a ton of parts out of this thing, and I'm not done yet. I'm sure I'll end up putting the fan into something else. The tuners are going to go into something else. Look, this last amp that I just did was a ball buster for me. It straight up was. It was very frustrating to, okay, completely rebuild the amp deck. Now I got to take all of that apart so I can get back down in here and get the band switch that had been mono banded. Every one of the input tuners was junk on this one that I just did. So I had to go through each one of them, and I had to balance it out with a variable capacitor on the band, add the capacitor, and then change the induction with the slugs. Very, very time consuming. Most sb220s will only take me 1 day to work on. I spent 4 on that particular unit. This is the problem that I'm running into, is more and more of the projects that are showing up are very heavily butchered. And they're taking longer and longer and longer to get done. It's because the damage to the units is more than what is led to be on the phone. I've got one over here. The guy says, just give it a freshen up. It's a 667. The only thing that's not 667, a Texas Star. The only thing that's stock on it's a Texas Star, and the rest of it looks like cobbled together bird poop. Well, it takes, I might as well go build them a whole new box. And that's what I talked the guy into doing, because I'm like, trying to repair that will take too much time. I thought that this last build was going to take me a day, maybe 2 at the most. And so every project that's behind that in the timeline has gotten pushed down. Well, that happens all the time. So now I'm, instead of running just months and months and months behind, now I'm running months and months and months and months and months and months behind. Because I'm going to get on one thing and I'm going to stay with it till it's done, and it's done 100% right. It's kind of what I've come famous for. So, look, the point is, I appreciate your all's patience. I appreciate you guys understanding that I'm just one guy trying to do the best as what I can with the stuff that gets sent up here. And I take turds and I turn them into diamonds. There's nobody else left doing that. I appreciate all the work, and I appreciate everybody's patience. Guys, if you've got an sb220 out there that you don't want to get repaired, you don't think anybody's interested in it, it's full of parts that I can use to help keep other people going. I will gladly buy it from you. The armor for this has gone down the road. The side panel for this has gone down the road. The lid for this has gone down the road. Half the capacitor bank, gone down the road. Filament transformer, gone down the road to Oregon. Plate transformer, gone down the road to Washington. Band switch, going to the Carolinas. I mean, the sun never sets on this equipment. These parts that have come out of this thing, they're all over the place. Call me if you got one of these and you want to get rid of it. Gentlemen, my name is BBI. Without a shadow of a doubt, I'm the biggest mud duck in Idaho. Come check us out, www.bbiamps.com, Facebook, Twitter, and of course here. If you enjoyed the video, subscribe. Help support me with that. I thank you guys. Let's see, I think the next one I got to work on is the one that caught on fire. Whoop whoop. I'll see you. Bye.